Video 6 of Chapter 6, we are going to finally finish up our discussion on binomial random variables. Now, at first we calculated binomial probabilities by using a tree diagram back in Video 4, but that was just way too much work. And then in Video 5, we discovered the binomial formula, which was great, but it was still kind of difficult to use our calculator to get the full answer because we didn't really talk about the combination formula and how to use that in our calculator. So we just focused primarily on the binomial formula in Video 5. But today in Video 6, we will finally figure out what are those answers to the binomial probability questions using our calculator. So we're going to look at these three situations here, which should look kind of familiar because these were the you-do problems from Video 5. So we talked about how to make the formulas work for these, but now we're going to figure out what are the final answers to these. So we had a shipping company that claims that 90% of its shipments arrive on time. The binomial random variable y is going to equal the number of on-time shipments out of a random sample of 100 shipments. So we have these three probabilities. One of them dealt with an exact situation here, and the other two dealt with more inequalities. And so we really need to consider those as separate types of problems. So we're going to have a calculator command that's going to work for equality events, which means just one event at a time. And then we're going to have a different calculator command that's going to work with inequality events, where it's one or more possible events. So first, let's start with the of equality event. What is the probability of seeing exactly 94 shipments arrive on time? So we talked about yesterday that if we wanted to use the binomial formula, out of 100 shipments, we want 94 successes. With a 90% success rate, we wanted that to the 94th power times a fail rate of 10%, and how many failures would we have left over? 6. So this was the work, but what does all that come out to be? Now let's use the calculator command to help us out. So the calculator command is called binomPDF, and it's in the same exact place that we have been using normal CDF earlier this year. So if you go to second variables to get to distribution, normal CDF is probably one of the first few things that you see up at the top. It's really going to be faster if you press up so that you start at the bottom of the list and work your way up from the bottom, but you can also scroll down, and it should be the A option here for binomPDF. Now, I've got this separated versus if you have a newer calculator and an older calculator. If you have a newer calculator, whenever you press binomPDF, it's going to ask for trials, P, and the X value. And then I'll also discuss the order that you have to put those in if you have an older calculator. So trials is the number of trials, and we said, how many trials did we have? We had 100 trials. So we type in 100. P is the probability of success, which is the 0.9 or the 0.90 if you want to include the 0. But now what we don't have here is what the X value represents, which is the number of successes. And how many successes did we want to see happen? We wanted 94 of them. So you type in 94, and then you hit paste, and then press enter, and you get your answer. Now, if you have an older calculator that just pops up and says binomPDF, and then the cursor's just sitting there staring you in the face, and it's like, okay, what are you going to do next? We got to put the numbers in the same order that we have here. So first we put in the 100, which again represents n, the number of trials, comma, which should be above the 7, if I'm not mistaken, comma, the probability of success, 0.9. So then we put in P, comma, and then we put in X, which again represents how many successes we wanted to see happen, 94. Then end the parenthesis, and then press enter, and you get what all that comes out to be. So how would this look like if I needed you to show me all the relevant work here? So here was the original probability statement. What's the probability that the number of on-time shipments, Y, is exactly 94? Well, that would be equal to the 100 combination 94 times 90% to the 94th times 10% to the 6th power, and then you let your calculator do that dirty work for you. And I got at my calculator, that comes out to be 0.05958 to 4 significant digits. So there's my answer. This happens about 5 to 6% of the time that I would see exactly 94 shipments arrive on time. Now, it is important, once again, that you show me the work, and it's also equally important that you come up with the correct answer. There have been times where I've had students show me the correct work, but then they screwed up in the calculator and they got a different number. So you do get partial credit, but not full credit in that scenario. All right, then we're going to use the other binom command. We had binomPDF, and there's going to be binomcdf. And the CDF works with inequality events here. So we're going to look at these two statements separately because they're going to work slightly different of each other because it all depends on which way the inequality is going. So where is binomcdf? It's right below binomPDF. So you just got to make sure that you select the correct one. The C in CDF represents a cumulative distribution function. So cumulative means we're going to be accumulating multiple probabilities with our inequalities. Now, the only difference that I really need to discuss here with you is what the x value represents to a binomcdf command. And the x value represents the maximum number of successes. And that's going to be useful for some problems, but it's not going to be entirely useful for other problems. We're going to have to kind of do a little workaround. Now, I know there are some newer calculators that will even say, like, do you want to go to the left, do you want to go to the right, or do you want to be in the center? And so then in that scenario, you don't really have to worry about this maximum number of successes. So if your calculator does say, like, left, center, and right, I think those are the terminology in the calculator, I would always just do left, unless you really kind of play around and you understand what the calculator's doing for you. All right, so first let's start with number 2 here. What is the probability, and we're still dealing with the random variable y, of seeing at most 92 shipments? So really at most 92 means we're not going to exceed beyond 92. So we want to see 92 or fewer happen. Now, we're also going to write out the work here. So this meant we could start with really the 0 scenario. So out of 100 shipments, we don't want to see any of them arrive on time. 0.9 to the 0th, 0.1 to the 100th, and then we could go all the way up to, and we would stop at the 92nd scenario. So out of 100 trials, we want 92 successes times 0.9 to the 92nd power times 0.1, and then we have 8 left over. Now, that's a lot of probabilities to have to add up, right? That's 93 separate scenarios to consider here. I don't want to have to type all that into my calculator, and I don't think you would either. So now we're going to pretend like we just typed all this into our calculator to get this answer. But what would we type in again? We would have our binomcdf. So I'm just going to put this down here off to the side. N was 100. Probability of success was 0.9. And then what was our maximum number of successes? Well, in this scenario, the maximum number was 92. Now, whenever we say this max number of successes, this will always go down to 0. And this is what happened. It started at 92 and it went all the way down to 0. So if I were to type this into my calculator, that would give me an answer of 0.7939. So about 79 to 80% of the time, at most, we're going to see 92 shipments arrive on time. Now, for the third scenario, now we're switching around the inequality here. So how would this one be written out? Of at least 80 shipments arrive on time. So we want 80 or more. So this means we're really starting with the 80 scenario, and we're working our way up to perfection. All 100 made it. So the 80 situation, this would be 100 combination 80 times 0.9 to the 80th power times 0.1, and we had 20 leftover scenarios. Plus ... 100 combination 100 times 0.9 to the 100th power times 0.1, and we didn't want any failures. So again, there's a lot of situations here. Not as many as the last one, but still more than what I would really want to type into my calculator. So how does this now work with binomcdf? So if I were to do binomcdf, number of trials is 100, probability of success is 0.9, and then remember, the x represents the maximum number of successes. So the maximum number of successes I want is 100. But what is going to happen here in the calculator is that it's going to start at 100, and it's going to go all the way down to x equals 0. And it's going to add up all of those probabilities. But I don't want to go from 100 down to 0. I want it to stop at 80. So how do I make it stop at 80 exactly? Well, here's what we got to consider, is the complement rule. So if I did this, if I typed this into my calculator, this is going to give me 1 or 100% because this is hitting every scenario from the 100 successes all the way down to 0 successes. So I don't really need to write this out specifically because this represents all scenarios. So the complement rule was we want to take 1 minus the scenarios we don't want to see happen that will go down to 0. So if I take 1 minus binomcdf, and I still want my 100 trials, my 0.9 probability of success, but now, what is the maximum number of successes I don't want to see? And I only get to say that I don't want to see it because I'm using the complement rule here. So I want to go from 80 up to 100. So really, what is that next trial down below 80? Because that would represent the max I don't want. And that would be where y was 79. So this, what's going to happen is whenever I subtract this is going to subtract away the x equals 79 case. It's going to subtract away the x equals 78 case. It's going to subtract away the x equals 77 case from all the scenarios, from all 100% of the situations. And it's going to subtract all the way down to the x equals 0. So if I had x equals 0 all the way up to 100, and I get rid of the 0 to the 79 scenarios, that's going to leave me with the scenarios I do want. So if I type that into my calculator, I get 0.992 to 4 significant digits. I have a very, very good chance of seeing at least 80 shipments arriving on time. Now, these are definitely the trickiest ones to be able to do because realistically, you should use the complement rule to solve these. The work that you write out, though, the work you write out here doesn't necessarily have to show the complement rule. You certainly could do 1 minus and then do the 0 up to the 79 case with your binomial formula, but you don't have to set it up that way. Okay? So these will definitely take a few practice examples for you to get used to them. So I have a you-do problem with 3 situations that deal with 2 inequalities and 1 equality statement. So I want you all to try these 3 scenarios out. And I want you to practice with just the calculator part. Don't worry about writing out the binomial work. Focus and try, how do I use binomPDF or how do I use binomcdf with these situations? And we'll talk about these the next day in class.